Subnetting in IP version 6 is much simpler than in the case of IP version 4, where sometimes it is necessary to convert the numbers from decimal to binary. In this case, there are 64 bits on the left side. These are the network address. 48 bits can be omitted because they represent the main network address. The other 16 bits can be divided into subnets. To divide a network into subnets, you only need to adjust these bits typing, for example, 0000, then 0001, and so on. Subnetting in IP version 6 is much simpler than it was before. Dividing the network into subnets, you might want to highlight one special subnet called the demilitarized zone. You can see the demilitarized zone in the upper right corner of the picture and below it. This depends on the implementation. There's a principle that states that a firewall cannot be configured in such a way that it protects both local users and external servers. Rules established to ensure the security of workstations will block servers. Rules that allow servers to work will not protect workstations effectively. It appears that more than one set of rules is needed, and thus, more than one firewall. The firewall should protect the high-risk dedicated computers. To achieve that, you need a firewall with 3 interfaces. For each of the internal interfaces, there is a separate set of rules that protect the network connected to this interface. Another way is to have 2 adjacent firewalls with the demilitarized zone between them. The rules that separate the DMZ from the internet are less restrictive than the rules set on the firewall between the DMZ and the local network. In addition to the subnetting that takes place in the network layer of the OSI model, you can also come across data link layer routing and switches that perform functions of routers. When you use 2 switches and they are not connected to each other, as in the picture on the top of the slide above, each of them creates a subnet. Computers connected to the same switch can exchange data with one another. Instead of using switches, you can also divide a network into subnets using specific ports. For example, ports 1 to 6 will constitute subnet A, and the rest will constitute subnet B. The final effect will be the same. Direct communication between individual sections of the network is now possible. In this way, the network topology can be adapted to the company's needs. Such a division is commonly applied for security reasons. However, this technology was not designed as a technology for security. Rather, it's a solution for a more effective and efficient local network. This solution has been implemented in 2 ways. The simplest kind of network partitioning, the Virtual Local Area Network, or VLAN, is a static partitioning. VLAN numbers are assigned to the switch ports. A dynamic partitioning consists of assigning the MAC addresses of hosts to VLANs. In the case of the latter, it is no longer important which switch port an individual connects to. It's important how the individual identifies themselves in the second layer. The switch is to control the frame sent in one Ethernet packet in such a way that they are delivered only to other hosts within the same VLAN. To make this possible, some additional information must be attached to the frame. Thus, a tag is added, which represents the VLAN membership of a given host. To ensure correct communication between the switches, it is necessary to make at least one port of each switch a trunk port. This is the transport port through which all frames pass, regardless of the tag value. In this way, the computers connected to one switch are able to communicate with the computers connected to another switch, provided that the tag values are the same. This is a standardized solution, but it's implemented under different names by different manufacturers. However, it does not influence security directly because the tags are not protected in any way. Data carried by the tag can be freely modified. During this part of our seminar, we touched upon the issues associated with the administration of computer networks. We said that thanks to subnetting, you can limit the area affected by potential attack. In addition, subnetting makes it easier to manage a network and improves its performance. It allows you to control data traffic easily. We discussed subnetting in IP version 4 and IP version 6. We examined the issues related to network partitioning in the second layer of the OSI model, VLANs. We mentioned several services that allow to further improve the performance and security of the network. Thank you.